Hello, everybody. Hope you're having a good weekend or had a good weekend. Let me see if I can stretch this out a little bit. And we're moving along through the course. And let's see, announcements. Well, the big announcement, of course, is that we've got spring break coming up next week. Woohoo! Off to the beaches, everybody. And then immediately following spring break is going to be the final exam based on the zybook material. Now, I've gotten a couple of questions from people who said, wait, on the syllabus it says that it's going to be posted on the 10th of March, which is before spring break. Well, what I did was I changed that around because I found that we had some extra room in the schedule and I want to spend more time on big query stuff. And I thought, well, why not give you the final exam after spring break? And so that's what this is. This is just moving it from before spring break to after spring break. So I hope that works out for everybody. So today our topic is going to be normalization. Now there's a bunch of other topics in the zybook for this week, but the big one is normalization. And normalization is something that you hear people talk about, that they pride themselves on their understanding of, and that they feel superior to you because they know how to normalize things and you don't. Well, let's just chillax a little bit and think about what normalization is all about. And then I'll give you some pretty easy to work with rules about how to actually normalize information. Well, first off, what is normalization? Well, it's getting rid of redundancy by storing that redundant information in separate tables. So instead of having tons of columns where we have the same information in those different columns, what we do is we just take that information and we say, well, there's only a few different kinds of whatever it is we're keeping track of. So we'll just have a link to using a foreign key to another table, and we'll store that information in another table. And anytime we need to show that attribute, we'll just point over to the other table, and that'll be the end of it. That's what normalization is about. So eliminating redundancy by storing redundant information in separate tables that are linked to the main table through the use of foreign keys. We're going to do all that foreign key stuff. No, we kind of already did that. But anyhow, so the big rule, by the way, write this down. That's what I always tell my classes. Whenever you have a one-to-many relationship, the foreign key goes in the many table. That's the main relationship that you're gonna have is one-to-manys. And in one-to-manys, remember, foreign key is the primary key. So the primary key from the one table gets stored as a foreign key in the many table. That's how you do one-to-many relationships. So normalization's only a concern for online transaction processing. So if you want to be an analytics person, you're probably not very interested in normalization because that's, it's just not what you do. So online transaction processing databases have, a lot smaller number of columns per table. They're narrower, but they have lots more tables and they have all those joins between the tables. So online analytics processing databases are purposefully denormalized. They take a normalized transaction processing database, they run a query that gathers all of these columns together and mushes them all into one result table. And that's the table that's used for analytics. And it's going to be way wider, but it's going to have very few extra tables associated with it. So purposely denormalize and redundancy is introduced. They put it in there on purpose so that when you denormalize, you create tables with many columns but very few joins. And this reduces the processing power required to run queries. In terms of processing power, it's expensive to do all those joins. And so when you have a transaction processing database, you're concerned about doing reads and writes and all that stuff all day long. Boom, 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 boom. And that works okay with normalized data that has lots of joins and lots of tables, because you're never really hitting all of them all at the very same time, with the big query. You're hitting, onesies and twosies. But in analytics, that's not the case. In analytics, you basically never write to the database except when you first generate that database. All the rest of the time, and it's not often, you're just running queries against that denormalized data warehouse, data lake, whatever you want to call it. And you don't really, your queries are run by a very small number of people. They're very structured, very organized. They don't happen often, and they almost never write to the database. So we've talked about this before, but there's a big difference between online transaction processing and online analytics. And the big difference is normalized versus denormalized, okay? So this is the chapter where we really hit that topic right on the head. So here's a normalized online transaction processing database. It's got tons of tables. Look at all those tables. Look at all those joins. If you were to have to query all of these tables all at once, with big analytics queries, it would be really expensive. It would take a long time and tie up your database management system just to do that. So what normally happens is that if you have a transaction processing database like this, Sunday night or something like that, about 3 o'clock in the morning, you'll run a query that queries all of these tables, and then the result table that comes out of that query is this big wide denormalized database table. And then for the rest of the week, your analytics people run their queries against that one denormalized table, and they never touch the transaction processing database. Why does that work? Well, because the analytics queries don't have to be exact. They're more in line with showing trends. And so if the data is a couple of days old, nobody really cares. But on the other hand, your transactions, those have to be on up-to-date data that is, reflects the current state, that, has all the current transactions in it and all that stuff. So very different. But this is transaction processing. And then I'm going to show you another one that. All right, so this is let's see, make sure I got this right. Okay, so here's an analytics database, and it is the Google Analytics sample data. It's used with GA4, and this is what we're going to use when we do our Google Analytics assignment number 1. It's going to be using all this. So, if you look at the number of tables, and by the way, this is e-commerce data from the Google Merch store, which you can access. So it doesn't look like that many tables here, right? There just, aren't that many. But what happens is all of these little parts here have a whole lot of extra columns in it also. So if you look at the number of columns that are in this data set, it's huge. This is a really wide data set. And this is all e-commerce information. And this is a good example of an analytics data set compared to where we have one table that's got tons of columns. There's so many columns that they don't want to even show them all at once. And we can look at the preview on this too, by the way. Yeah, and it just keeps on going wider and wider and wider. Oops, I'm going I'm going side to side. So it just keeps on going wider and wider. And look at some of these are completely null. There's, there's just nothing in there, and yet we keep them. Why? Well, because we would, this is for analytics queries, and sometimes those don't really, we don't need to, have all that data in there. Device operating system, all kinds of stuff. Device operating system version not available in demo data set. So this is anonymized information, and they make it so that you can't tell who actually does what transactions in the Google Merch store. But you do get a chance to see most of the columns. Is that fair? Probably. And you can do a whole lot of work with just the columns that are available to you. So anyhow, so this is an example of a transaction process, or of an analytics data set. Let's go back to this. So normalization, there's a few rules for doing this. We've got first normal form, second normal form, third normal form, and then Boyce-Codd normal form. There are fourth and fifth normal forms, but they're not used commercially. They're more of an experimental thing. So these are the rules that you can use to do this. And this is out of your Xi book, so I'm not going to read them to you. But what I will do is I'll walk you through them really quickly in my shorthand notation. So Charlie Border specials. First normal form, as soon as you have a valid primary key. So you got that first primary key, and if there's no duplication in the primary key, and there can't be because that violates all the rules for databases, if you have a valid primary key, you're in first normal form. If your primary key is a, got all those non-key columns depend, blah, 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 blah. If your primary key is a simple primary key that's generated automatically, it's meaningless. It's a customer number 00001 versus customer number 00002. That means nothing. There's nothing that ties that primary key to the values in the table. Then, bada bing, bada boom, you're in second normal form. To get to third normal form, what you have to look at is the non-key columns. And so if you have a non-key column, so you've got your key column over here, all of the other columns, if there's dependencies between those non-key columns, if you have a table of new cars and you have one column that says car color, and then you have another column that says, car trim, what's the package that you have, well, all the luxury features and everything. If every brown car, so in the color column it says brown, if it's the luxury edition, then you have a dependency between those two non-key columns, the color column and the trim or package or whatever you want to call it, column. That's bad. So if you don't have that, then you're in third normal form. Now, why is that bad? Because if every car that's brown has the luxury trim, don't bother including the luxury trim column. Just say brown. And every car that's brown has the luxury trim package. So you don't need that. The luxury trim package part becomes redundant. And that's what we try and get rid of when we normalize a table. And so what you might do in that case would be to have a column that links the color to the trim package, and you'd have a different table that had the match between color and trim. Brown, luxury. White, XL. Red, sport. That's how you would do that. And so If you don't have that, then you're in third normal form. Now, Boyce-Codd normal form is a lot like third normal form, except that where we say non-key column, we eliminate that. So it can be a key column or it can be a non-key column. If there's any of that redundancy built into there. If all of the cars that start with a VIN number of X27, if those are the luxury editions, X27 is your primary key, and if there's a dependency between X27, the primary key, and the trim, that's not in Boyce-Codd normal form. But if there's no dependencies like that, bada bing, bada boom, Boyce-Codd normal form. So the process, how do you go about normalizing a table? Well, here's the official version. But the key idea is that you start with first normal form and say, am I in first normal form? Yes or no. If you got a valid primary key, you're in first normal form. Then you go to the second normal form. So, well, if I'm in first normal form, am I in second normal form? Well, is the primary key, is it everything in there? Is it a simple primary key? One column, meaningless, probably auto-generated. Then you're automatically in second normal form. Great, we're in second normal form, but are we in third normal form? Well, let's check. Do we have any dependencies between non-key columns? Are there any of that, all brown cars have the luxury edition? If you don't, boom, you're in third normal form. And then you say, oh, okay, I'm in third normal form. Am I in Boyce-Codd normal form? Then you look for the dependencies between the non-key, all of the columns. So if there's no dependencies built into your database, then you're in Boyce-Codd normal form. That's how you do it. So here's my version in regular words. Start with first normal form. If you are, proceed to second. If you're in second, then go to third. Are you in third? If you are, then are you in fourth normal form? What you'll find is that to do this, you're going to have to move things around. You're going to find dependencies built into your columns. And when you do that, that's when you have to think about, okay, can I leave this in my data set, or do I need to form a secondary table, then link from my first table, my big main table, out to that secondary table? And that's what the actual process of normalization is all about. It's that going through these different tables, looking for dependencies, and then resolving those dependencies to make sure that there's no extra information contained in your columns. And that's what normalization's about. BigQuery links, remember, we're going to get to this right after the final exam. And we're going to have our Google Analytics assignment. That'll be the BigQuery assignment number 1. I think you'll find that one pretty interesting because it gets you a chance to really do something cool. And then we'll have our BigQuery cookbook that we'll be using as part of that BigQuery assignment number 1. Then we're going to start heading toward the Data Looker or the Data Studio. I think the two names resolved to the same place. They just changed the name. I don't know why they changed the name, but they did. So Data Studio, let's see, and Dubai Pulse, that's just another data set that's available out there. So get yourself familiar with BigQuery. Get yourself, run through some of the tutorials out there in LinkedIn Learning or whatever. Try it out. Open up the console.cloud.google.com, and that will allow you to make sure your account's all set up for this, because This is all done through Google, so we got to be nice to Google and live up to their requirements. And then we're going to have the assignment number 1 with the BigQuery cookbook. That'll help you out a lot in terms of how to do this. One of the main things you're going to notice is that doing especially the BigQuery assignment number 1 is that you're going to be using examples, and we're going to be not writing, out of whole cloth. We're not going to start with a blank query line. We're going to take examples that do something similar to what we're interested in, but not quite. And then we're going to modify those examples to make it into what we want it to do. And as far as I can tell, that's how people do computing these days. So, I think we're okay doing that. But yeah, there's BigQuery assignment number 1, and here's some of the questions, and we'll look at this again and all that stuff. And then the project proposals and stuff, we'll go over that right after the spring break. We'll talk about that. I'll give you formats and all of those things that are interesting for you. And then we'll figure out how to do the dashboards and everything, and it'll be cool. I think you'll have a great time working on this project, and I hope that it's something that's really enjoyable for you, and it'll be, for a lot of you, it'll be your first analytics kind of thing. Oh, and by the way, I have some resources to help you to figure out what dashboards are and how they work, and how to organize them a little bit. But there's going to be questions like color choice. There's going to be questions about how do I tell a story with data. All of those kind of things, which are really the human side of this, which, since we're humans, that's what we should concentrate on. That's the interesting part. And so I want you to embrace your inner human and not your inner technologist. And I think that's it. So have a good break, everybody. I won't post another thing until after spring break. Next week is spring break, and we'll have our final exam on the 20th, and I'll send out some reminders and stuff. So, it's not going to be hugely stressful. Finish up everything in the zybook. Use the spring break to do 2 things. 1, figure out BigQuery. Yeah, go through some LinkedIn Learning stuff, because you'll have some time. And 2, make sure that you're all done with the zybook. I don't want to deal with any zybook stuff after your final exam. Okay, so take care, everybody, and I will talk to you soon. If I can find my cursor.